Hello everyone, let's get started. So, I'm Dimitry Petrashko. I'm here to give you a story about what is migration to Dotty going to look like. And this is not a complete story yet. The migration is yet to start. The Dotty hasn't yet shipped its first technical preview. I want to take advantage of this talk to invite you to provide us feedback and share your concerns. This talk contains our current opinion on what we should consider when working on the migration, and it describes the effort that we're doing already to ease this migration in the future. But this is a dialogue between us as compiler developers and the community, so please join us. Okay, so as you all know by now, Dotty is the new compiler for Scala-like language. It's not a compiler for Scala as it is now, because it's a compiler for a language which we want Scala to be. There are some features which we added. There are some features that we decided not to carry over, and that's why there will be a migration. It's being developed at the laboratory at EPFL under supervision by Martin Adursky. To make it clear, it's not in any way ready for production use. There are nice features that's worth trying out, but don't bet on them staying there forever and don't build your entire business on it yet. Okay, and for now, we're pretty much decided that Dotty will become Scala 3.0. The question is when, and the most important question is when will be what's the right moment for us to make it 3.0 to make sure that the entire community as a whole can go together with us into the future. Okay, so who am I? I'm Dark Demius on the internet. I was the first to join Martin's effort in developing Dotty. So I co-designed a lot of foundations of Dotty with Martin. I also started several projects around Dotty, which are Dotty Linker and Optimizer. And currently, I'm writing my dissertation under supervision of Martin about Dotty internal architecture. So the agenda of this talk is, I'm going to cover first what is the future which we're currently building in Dotty. What are the new features that we are developing actively? And we want to invite you to provide us feedback on which of these features you think are important to you. We want you to try out these features and see if they work the way you expect them to work. And we want to make sure we have more people trying them out so that we know all the considerations when adding it to a stable language. Then there's also a question of not only building the future, but of maintaining our common past. Scala has been in production use for quite long. And it's important for us when building the future version of Scala to maintain all of our heritage, to make sure that companies who are using Scala to build their business on top of it or can carry over and have no disruptions in their business. It's also important for us to maintain the spirit of experimentation. A lot of people joined Scala first because they felt like Scala allows them to do something that other languages don't. Scala allows them to express themselves either more efficiently or more safely, or in another way that you will prefer Scala to express you better. We want to make, that's the right moment now for us to make sure that Scala still serves the purpose which made you before consider making Scala your primary language. So the main considerations here for maintaining our past will be binary compatibility. How do we coexist with previous stuff built in Scala, which was compiled before? How do we coexist with Java stuff? How do we exist with other languages such as Kotlin? Another question is source compatibility. We wrote some code before. How do we make sure that you can still compile this code? How do we make sure that if you use some features that we no longer support, there is a straightforward path for you to make your code compilable? How do we make sure that when you have this old code base that you wrote, which uses Scala as a language, but a different flavor of Scala that doesn't have all the new fancy features that we're developing now, you're able to start using these fancy features without requiring to rewrite your entire code base. And as a pinnacle of all this consideration, there is a Dotty community built. Okay, so let's start. So, both Martin and I have a problem with our talks about Dotty. The list of either features or people or anything related to Dotty doesn't fit into slides anymore. So I arbitrarily chose some, and I arbitrarily dropped some to make them fit. I'm no longer presenting people who worked on Dotty as I did before, but I will just tell you that that's a common effort by both EPFL folks and Waterloo folks and type safe light band folks. Okay, so among all those features, which there are quite a few, what you can see is many of them are actually not just a compiler features, they are language features. They provide you a possibility to express new kinds of libraries, new kinds of APIs. They provide you something that you weren't able to do before. We're also implementing some other cherry-picked features again, which will also have a lot of influence on how you build software. In particular, there is a pull request now implementing native HList and HMaps and record types. This is very important because the intention is to allow you to use techniques which were developed by our community outside of the language, which had some disadvantages. They didn't scale in some use cases. They had performance that was able to improve. We believe that this is an important use case. We want to make it possible to use those powerful features without having back thoughts about whether you should. Now we're adding them in a strong way to the standard library and what will be standard compiler. We need to all decide what will they support, how will they work. The same happens with all the features. We're collaborating on Scala meta macros with Eugene and Twitter. We're making sure that it fulfills all the requirements that everybody has. So please join us. We also have some stuff which doesn't necessarily have to do with the language, but it does have to do with your everyday experience, like build tool. We're collaborating with Chris, who's helping us be able to compile and bootstrap Dotty, both using SBT and both using CBT. We're collaborating. We have put a lot of effort in making sure the compiler is faster than the current one, because that's what you do every day. You compile stuff. You rely on type checker finding your errors. But if type checker is slower than you in finding your errors, there is no point in having type language. So, okay. So a lot of features are coming. All these features will allow new ways to build libraries. In one way or another, libraries will have different APIs. Libraries will be structured differently, or they will work differently internally, making them more efficient or more safe. We should be clear about it. The language is no longer just syntax and compiler. The language is also ecosystem. When we're talking about Scala 3.0, it's not just releasing a standard library and releasing a compiler. It's making sure that you're able to do what you intend to do in your business logic, in your big data, web forms, or anything. You're able to do it efficiently. And in many cases, those features aren't supported by standard library because standard library tries to be smallish enough to make it be standard. You may have some things in the ecosystem that we don't agree to make standard. We have some flavors, preferences. We want to make sure that all this is still Scala 3.0. Without maintaining this ecosystem, Scala 3.0 won't be Scala. It will be something 3.0, but not Scala. Okay, so the future is arriving soon. There will be 2 or 3 years till Dotty will be renamed to Scala 3.0. It will coexist for quite some time with Scala 2 releases because not everybody can put time at the same time to do the migration. But what happens now is that we're pretty sure on what the paths we're going to follow. That's a moment where we've committed to where are we going. Now, the question is, what do we do on this path? If there are some features in Scala that you want to work differently, if there are some improvements that you ever thought would make Scala a better language, that's the right moment to do it. Because after Scala becomes stable, we won't be able to put, let's say, half a year into discussing a feature which will change the Scala as a whole thing. We don't have multiple opportunities to release a really major version of a new language, because that's a big leap of faith. For those who are thinking that there are things that bother them in Scala, that's the right moment to join us and share with us your opinion and propose either a way to solve it, or maybe we have a way to solve it that you didn't consider before. So, aside from our future, which is awesome, we also have our past, which is also awesome. Otherwise, you wouldn't be sitting here. So we need to maintain this awesomeness to have both awesome parts. So we need to maintain the past awesomeness and build on top of it. The migration will require multiple things. First of all, we need to make sure that at the time that not everybody migrated yet, you can build on top of stuff. Okay, so the migration part that I'm going to cover soon will tell you how to cover new features and how to stay compatible across two versions of Scala, and how to make sure after you became compatible across two versions of Scala that you still stay compatible. Both compilers are actively developed. If you became compatible with Rust at some moment, well, they didn't give you a promise that they're going to maintain compatibility before they released. It's the same with us. Before Dotty became Scala 3.0, we may make changes. We will consider every change seriously if it's worth it, but we didn't yet give you a promise that everything will remain stable. So the first kind of stability and the first thing that you want to know in order to try new features is you don't try new features in isolation. You want to see how something works in, let's say, your actor application or your streaming application. You don't try features in a hello world because it doesn't actually show the complexity of the area. So because of this, you need to actually integrate with existing code. Though Dotty is a major version of Scala compiler, and it doesn't have to be binary compatible, major versions of Scala, such as 2.11 and 2.10, or 2.12 and 2.11 for the matter, are binary compatible between each other. Dotty does best effort compatibility with 2.11. We're trying to make sure that you can compile code in Dotty, and let's say inherit from traits defined in 2.11, use code in 2.11. We're not putting too much effort in it, which will stop us from developing new features, but we're putting enough so that we can try stuff out. In particular, Dotty is more or less what Scala was at 2.11.5 time, somewhere deep inside. We're planning one day to become 2.12 somewhere deep inside. But currently, because most of the ecosystem still is on 2.11, that's a place which better fulfills our goal. If you are interested to try how Dotty features will work in your system, you can try it in a single file. If you're some big company who is using 2.11 and you want to try something, you can easily do it. Aside from this, from best effort compatibility, there is an active discussion in the SIP process about stable ABI. And I'm going to go deeper into what it is, but not too deep. So stable API, that's a tailor-like annotation, which is going to fail compilation of a class if this class uses some features which across future major version of Scala may become binary incompatible. So it doesn't check binary compatibility. You should use Mima for this. But it does something that Mima doesn't. Mima doesn't tell you how easy would it be to maintain binary compatibility. If you were to release some kind of version of a library on Maven, and after the fact there is a new major version of Scala, and you want to release a new version, and now you have binary incompatibilities, it may be very hard for you to make them work after the fact. Stable ABI allows you to look forward to the future and be prepared and know upfront that if something successfully compiled with stable ABI before, it will compile in future, and the compiled versions will be binary compatible with each other. This provides something similar to Java-like binary compatibilities. Java actually provides more. There are things to do with reflection. There are a lot of considerations which Java does on top of this, but that's a nice start. Why this is a SIP which progresses one of the hardest SIPs to progress, because this SIP is a promise which compiler developers, multiple teams of compiler developers now, have to commonly agree that we're giving to our community. We're very careful about giving you a promise because we want to keep to the promise. We're considering a lot of small technical details which look into our past and tell us how hard was it to develop some features. To give you one example, we can try to promise you that the trait methods, which are now implemented using default methods, will be binary compatible because there is a way to implement it in JVM. But we don't want to do it because it may stop the evolution. We may find a better way to do it. That's just a first release, which is 2.12 or Dotty, which have this feature in the first place. We're not sure that we won't learn more about it. Maybe we'll find a better way to do it, and we don't want to stop the thing from evolving the language. But still, we want to provide you guarantees. We want to make sure that the common use cases are covered. So there's a lot of negotiation going behind the scenes now. The important part of stable ABI, which is my main motivation idea behind it, is if you are to develop a library which as a library entirely succeeds in compilation with stable ABI, this library does not depend on Scala version. You can ship this library for all versions of Scala, including Dotty, and you don't need to cross-compile. You won't have this problem with publishing where you can't migrate to 2.11 or 2.12 because some library that you depend didn't publish before. The thing that it published before works for you now. It's a higher level of reliability that compiler developers give to library authors, and library authors are able now to give to customers. If you were considering a library before and you have thoughts, well, whether this library be maintained and whether upgrading this library will be a hassle. If you have a library which succeeded compilation on this thing, it doesn't need to be upgraded, like in Java. You can just use the old version. Okay, now when we're done with stable ABI, there is source compatibility. So Dotty is highly source compatible with Scala 2.12. There has been a lot of changes in Dotty which inspired changes in Scala 2.12 and reverse changes in Scala 2.12 which made their path into Dotty. But there are differences. Many of these differences are intentional. For example, we intentionally decided not to have procedure syntax. We intentionally decided that in Dotty, lazy vals will be thread unsafe by default. And if you want to get a thread safe one, you should annotate it was volatile, as you do with normal variables. We're making it more consistent, but this may break your source. There's also a very strange thing which may happen in case you have implicit values for whom you ask compiler to infer the type. Depending in which order compiler compiles stuff, it can infer different types. And there are multiple puzzlers which, depending on compilation order, will actually do the different things. They will evaluate differently, and every time you're compiling this project and shipping it, you're playing Russian roulette in your production. You don't know which out of the two things it's going to do. So, and of course, there are fixes to type inference. We're always looking to find bugs. We're always looking to make Scala a safer language, make type inference either more precise when we can, or more correct where we can. This all can contribute to that your source won't compile as is, and it will need some modification. Hopefully, you can try it out first. There's an SBT project for Dotty, which just allows you to plug into your build and try it out. It's very likely that because somewhere you're definitely using procedure syntax because everybody uses, well, there's something which will need to be changed. For this, there's a Scala fix. This is a project which started as refactoring for Scala, but aside from this, it has rewrites. And in particular, it has rewrites which make your code more Dotty compatible. It's able to convert your procedural syntax into your entire code base automatically into the syntax supported by Dotty. It's able to smash volatile and very lazy val. Very easy thing. It does best effort in precisely writing the type of error implicit that you had. But to make it clear, that's the best effort. Sometimes the types inferred by compiler, you can't write them in the first place. So you may have some source which more or less compiled because of compiler something buggy thing. Compiler inferred a very precise type that you're never able to write by hand. Maybe because it's infinite or something. You can try to write an infinite type, but good luck. So yeah, so we're making sure it's easy for you to try it out. And we're trying to ease the migration by developing tools such as Scala Fix, which will help you with source compatibility, by developing stable ABI SIP, which will help you with binary compatibility. So there are known caveats, which so far are the things you should think before trying to convert your project. In particular, so far, we don't intend to add Scala reflect macros. We're working to support Scala meta macros, but Scala reflect macros are next to impossible for us to support. So to make it clear, half a year ago and a year ago, when I was giving a similar talk, I was naming one more feature which we didn't intend to support, which was structural types. Well, now we do. We found some corner cases, which we consider corner cases, but they're very useful. And we can't provide a straightforward migration strategy. So we decided to bite the bullet and implement it. We still are not sure if this feature was worth in the first place. Maybe it wasn't. But now, after ecosystem has valid usages for it, we can't just take it away. We carry it over with us. That's our common heritage. We can't just turn our head on it. There are other things that if you're currently cross-compiling with JSON native, our plugin is not, at the current moment, very friendly to cross-compilation across multiple platforms. We're fixing this now, but if you're a person who, as George, started checking out his source code now and trying to see if it compiles, then if you're cross-compiling with these plugins, they may have conflicts. We intend to support them later. We just didn't get to do it yet. We're actually working on it now. OK, so at the pinnacle of all of this, we need to somehow check that it works. We're building this stuff. We're asking you to try it. Well, we don't want you to be the first people who know that it doesn't work. So we try it on our site first. We have something called Dotty community build. In this repo, we maintain Git submodules which point to versions of some community libraries which we arbitrarily chose because we either knew them well or liked them in some specific particular moments that we make sure that they compile with Dotty. Commonly for them, it meant adding several lines to builds to make sure it uses actually Dotty to compile stuff, running Scala fix, and making sure it compiles. Why we do this? Well, we need to have a good grasp on how hard is it to migrate. We're working in compiler. Honestly, compiler is a very special code base. It's very unlikely to be similar to your business code base you're working on. It's very likely that the way how you use Scala there is at least slightly different, or maybe entirely different than the way how we use Scala inside compiler. So we're making sure that different code bases written by different people can be migrated easily. Well, compiler is evolving. We want to make sure that if it used to compile with previous version of Dotty, it still does with the current nightly. And you can actually see that this repo inside itself contains a hardness to give a version of nightly of Dotty and try to compile with it. We also use it to develop the migrations using Scala fix. These repos don't actually contain the changes which are migrating them. We just run Scala fix on it automatically. We make sure that the versions of Scala fix are still able to migrate them correctly. And of course, check SBT plugin. Because, well, there is a lot of dark magic which may be happening inside your build. There are some plugins which use more dark magic than the others, like Scala.js and native plugins. And we want to make sure that those projects, if the commonly used plugins by common projects, coexist with Dotty plugin. Okay, so here's a short list of the projects which are currently in community build. This is the shortest list because the way it started is like every person in our team just took a single library and migrated over a day or two. We tried hard to make sure we don't bias over a specific way of doing stuff. So that's why we also choose some type level libraries, because they do stuff differently. We also try to take into account which libraries are building, what libraries does ecosystem build on top. For example, Scala test and Scala check were chosen because almost everything in our ecosystem relies on them in one way or another. Even if you don't think that you do, well, likely your dependencies do. So I want to thank you for following my talk. I want to ask you to collaborate with us, join us to make sure that we all go together towards Scala 3.0 and to make sure that it's going to be our bright future, not our big divide. Thank you, and please ask your questions.
Thanks for the talk. There's an effort to integrate with SBT, but is there any plan to also integrate with Zinc, SBT Zinc?
Thanks for a wonderful question. So in my mind, integration with SBT and Zinc currently are synonymous. Most of the stuff that SBT used to do, which is related to actual build, is now in Zinc. So, and it will be even more in Zinc when SBT 1.0 will ship. So I would say that we're actually integrating with both of them, but because they're kind of in the flux in the moment when we have this transition from 0.13 to 1, and some versions of 0.13 don't have Zinc in the first place, some versions do. So it's a tricky question to answer because it's in details. But the idea is we integrate with both. So if you're using Zinc for Maven, it shouldn't be, we didn't try it yet, to be frank with you, but it shouldn't be hard to make sure that you can compile stuff with Dotty in Maven. Contributions are welcome. We'll be glad to help you on making this work. Thank you for a wonderful question.
Okay, thanks for the talk. I have a simple question. What are the features of Dotty that are supposed to be like killer features that are supposed to be used by everyone in the nearest future? You know what I mean. So,
okay, thanks for an awesome question. So I'll bend your question a bit. The thing is, I believe that Scala is used by different people differently. And I don't feel like qualifying that there are features which are killer features for everybody. There are some which are killer features for me. For me, the ones which I like a lot are static methods and fields. I'm a performance guy originally. Static methods and fields allow you to do stuff faster. It allows you to do stuff which is better optimized by the VM. But once again, I'm not sure how many people share the same taste with me in this regard. And for the same reason, I mean, I'm starting this linker thing. I believe it allows new ways to code in Scala, because you can code and then rely on your code being transformed to more efficient form. It allows you to build stuff which before you didn't build because it will be ridiculously slow. But now it works, and it works great. Other people who I've seen like other features. For example, they like implicit awesomeness, like capabilities. It's nice if you're trying to control everything around you, because it allows you to have a more reliable and a standard way to do it, which integrates well with the language. I believe a lot of people will like it a lot. Some people like trait parameters, because now there is one less consideration why you would make a class. But you can have some other people who don't like it, because now how do you choose whether to make a class or not? So you have one more reason to choose to make a class. So Another feature which I believe almost nobody will notice, but I think will have huge impact on our ecosystem, is this, optionless pattern matching. Scala historically has been using quite a slow way to perform pattern matching. And there has been an undocumented, unstable, unpublished, secret way to do it without options. Now we make it public, and now we standardize on it. This itself will allow us, every time you pattern match in a case class, every time you do any pattern matching that you do almost all the time, to allocate less, which will make your code run faster, which make your code optimized better. It also makes pattern, in the process, we also made pattern matching more principled in a sense. But it's a double-edged sword, because we removed some unsoundnesses from it. Some code used to rely on some unsoundnesses. Some of this code was in standard library. Thanks for a wonderful question. Another feature which I guess Martin will like a lot is nice enumerations. Because now we have a very nice way to actually have something that I guess sealed classes were originally intended to be. Yeah. Okay. Thank you. Any other questions?
So I like the idea of implicit functions conceptually. But after the talk yesterday, and I did a bit of research online, I do sort of question the implementation a bit. The moving of implicit parameters into the return type seems a little confusing to me. Mm-hmm. So I guess I'm sort of wondering about maybe the justification for that, or what you're thinking.
So that's a very interesting question. There is a principle of Bjorn-Stroustrup that if you have a new feature, people normally ask it for it to be very verbose, so they can clearly see it. So that every time you open a source code, you can see that it's there because it's a new feature, is dangerous. But then when they get used to it, they want it to be silent. So when you start with a feature and you're developing your language carefully, then you'll start with features which are very verbose. But then later, you will need to make less verbose. And it's very hard to do this in retrospective. So I think the nice way to solve this problem is don't invent a new way to do stuff. Use stuff which is already in your language in one sense or another. So what we're doing here is we're using type aliases which are already in the language. Before this, you have multiple ways how to make type aliases do crazy stuff. We're not making one more crazy thing because you can actually do most of the stuff already. You can have type aliases which themselves expand to stuff which has an apply later which has implicit parameters, which is not far from what we're doing. We're just making it more systematic and actually nicer. So what I would say is that we're taking features which before this were done in these ad hoc ways, and we're providing a way to make them both more general, more safer, and we're providing a straightforward highway on where to expect them. Before this, you could have found these features somewhere behind the bar stabbing you. Now, you have a highway. On this highway, you have this indicator, type parameter, either contextual or viewed or something. You can control-click it. It shows up in the IDE. I actually think that the current proposed version is a very nice strike in the middle of the two possibilities discussed by Bjorn-Stroustrup. We're not introducing new syntax. We're using existing syntax. So it's seen on the source code. There is a syntax for this. But at the same time, we don't need to discuss whether we will first have a complex syntax or not. If you follow actually the discussion of enums, most of the discussion there has been about syntax. Because, well, that's a new thing. And after we agreed on syntax, it will be hard to change it. Here, I believe the power of Scala is that Martin was able to build building blocks which in the future are actually expressive enough to build new features on top. Scala, so that's my opinion. but I'm pretty sure a lot of other developers of other languages won't share it, but I believe that Scala is a very simple language, actually. If you compare it with Ruby, Python, even Java, Java specification is a ridiculous book. Scala is very simple. It's just that the features combine really, really well. And it makes a very expressive language, and while being both simple as a language by having complex usages, which don't require the language to become more complex. Yeah, thanks for a wonderful question.
Can you expand on multiversal equality and what that's about?
Multiversal equality. Nice. So, in the current Scala, you can compare everything to everything. So, in Scala, you can also have implicit conversions, which are able to, well, convert something to something. What it leads to is that we have a wonderful method called equals equals, which is more or less the only method on which implicit conversions won't trigger. And then, well, it's very irregular. Also, that's from the point of view of, let's say, refactoring. So if you're refactoring your code base and you somehow happen to, do equals equals, then the type system won't save you. You can compare everything to everything. It does different thing now, but it still compiles. There's also a fundamental ideological question whether you should be able to compare everything to everything in the first place. So multiversal equality is a very interesting proposal similar to the discussion of syntax, which tries to strike this middle between being able to compare everything to everything, which our platform actually requires. We compile to JVM, and being able to safely compare to stuff. So it proposes a way to use implicits to indicate whether you can compare something to something. More precisely, it uses a mechanism of ambiguous implicits, that if there's something that you're comparing to something that it didn't expect to be compared to, it will get two ambiguous implicits. It wouldn't compile. Similarly, we're building on the feature which already existed. We're just using it in a new way, which is library defined, but allows us to provide more safety. In a sense, that's kind of the opt-out version. So you're opting out of universal comparison and opting in into multiversal. You provide domains in which you're willing to be compared to. If you're comparing outside of this domain, you will fail. If you don't know which is your domain, you're able to compare with everything. Thanks for a wonderful question.
Is there an estimated timeline for Scala.js support?
Okay, so Scala.js support is a tricky question again, because Scala.js requires a different notion of dependencies, because they more or less always compile the entire world. Building a prototype of Scala.js now, we actually have it, but we just ask people not to use it, because there may be strong reasons for us to build it differently. And we don't want people to, start committing into the way how it works, because that's a nice moment for us to reconsider. We have a prototype for Scala.js. It doesn't support the entire language. We just made sure that we can build a prototype and there is nothing in Dotty that stops us from doing it. There's also a question that we want to focus our effort. Most of our Scala ecosystem is still on JVM. We want to make sure that, we put our effort in the same fractions as an ecosystem sizes. So we've put some effort to Scala.js, but not too much to make it, not make Dotty be a Scala 3.0 GS. Thanks for a wonderful question.
I'm going to ask you to expand on another one of these. The any value classes, I should say. I know that there's been restrictions in the past, and also there's been some cases where it doesn't behave the way I was expecting. Is there sort of going to be a lot more work on this, and what would it look like?
Okay, so with value classes, the effort so far was mostly concentrated around lifting restrictions, which were originally implementation restrictions, but they just stayed. Let's see, in value classes, currently in Scala C, you can't have value class over a value class. Why? In current Scala C, you can have value class over unit. Why? The answer why is actually a meaningful answer, but it requires to go deep inside implementation. So it shouldn't be very concerning about this. We lifted those restrictions. At the same time, one more thing which is nearby here is this phantom types. A lot of use cases which previously I believe were covered by value classes are now better covered by phantom types. So let me quickly explain what they are. Phantom types are things which there will be none in runtime. They're present only during compilation. They're more or less your proofs. If your proofs that something exists or something does something, well, maybe you're not interested to execute this proof in runtime. You rely on this, you believe the static type system that it done it right. So if that was your case, then we have a better thing to do it. If you're asking the question of that the value classes can be boxed in arbitrary location, or let's say that calls to interfaces which value classes implement are actually boxed, then so far I think it's actually better done to tooling such as IDEs and linter. Linker here does some effort to, it doesn't actually do value classes as the normal value classes. It has something which is both stronger but has bigger requirements. It analyzes your code base and sees if something can become a value class in a sense. And it can peel multiple layers out, which is effectively becoming a value class in some sense or another, but it can do it on a better granularity, let's say. So just to make it clear, I'm discussing what it can possibly do. It's not something that we intend to ship in the first version or something. If you have a list of tuples, that's a list which has a pointer to a tuple which has pointers to elements. Well, you can actually if you were able to make lists have two fields, you can just put the tuple inside. Now, there are some requirements for this to be sound. Actual in tuples is always not sound because somebody in your case, for some reason, does reference comparisons in tuples. For case classes, it frequently actually is because somebody does a case class which uses only a small part of the code base. Then you can remove this case class entirely. All the cases where you use this case class locally, you can just deconstruct it into fields. All the cases where you pass this as an argument, you can deconstruct it into arguments. If you store it in the heap, if you can predict where you store it in the heap, you can deconstruct it into fields. Now, the question becomes now a JVM-ish question. If everything goes right, it optimizes well. And that's where the difference with value classes is. It provides you more performance if it triggers. Now, I've been thinking a lot on how to make it easier for developers to track when it triggers, and that's a very complicated topic because there are multiple optimizations which work together to make this happen. And just saying which one of them failed isn't very informative. But our explanation is actually in a series of them failing in most cases. Yeah. Thanks for a wonderful question.
So there's a ton of features you're planning for Dotty. I'm wondering, how long do you expect Dotty and Scala 2 to coexist? And are you worried about a Python 2 to 3 split in the community?
So that's a great question. So in order to make sure that Python 2, Python 3 doesn't happen, this talk happened. So Python 2 and Python 3 are two different runtimes. It's possible to have Python 2 call into Python 3. But either your production people will hate you, or you will hate yourself, or both, if you try to make it happen. What is the intention here is to make sure that those two languages are the same language. They share most of the ecosystem. They share part of the ecosystem which makes sense sharing. They compile from the same source. They have tools which make sure that if you need to convert, you can convert. Now, we should be clear that there are some business considerations, customer relationship things, where you can't easily upgrade, and that's why we still have Scala 2.11. That's why all software has versions being maintained. And when Dotty will be released, there will be bugs in Dotty. I'm actually very glad that Dotty has a very strong self-checking mechanism, and we haven't seen serious bugs in Dotty for quite a long time. We actually rarely see even minor bugs. And when we see bugs, it's very easy to find how to fix them. But it's pretty clear for me that there are some, let's say, corner cases feature or behaviors of the previous compiler that we didn't implement. For example, how many people know here that there's magic inside Scala 2 backend which is there to support Android? Seriously, I didn't get what this magic does. I didn't copy it. I want first somebody to come and explain me what this was intended to do, or what's the use case which is not covered. I don't want there to be a lot of code base carryover from the previous legacy system here, which I have no clue what it does and why it exists in the first place. So there will be systems or solutions where people will still need to exist in Scala 2 branch for quite some time. Somebody may have modified compiler a lot. Well, we have a different compiler now. The people who I think it will be the hardest to migrate is people who made a lot of modifications to the compiler itself, made plugins which changed the semantics of the language, and used hacks to implement those. Dotty has self-checking mechanism. Your hacks are unlikely to work. It will say that you're doing something strange, you're breaking stuff, and it will fail you early. Yeah.
As long as the print statement isn't changing, I think.
Sorry?
As long as the print statement isn't changing, like in Python, I think we won't have as many problems for sure.
Yeah.
And one more question. I know a big reason for the new architecture for Dotty is to try to be more functional and make maintainability easier. Have you, now that Dotty's been in development for a much larger number of years, have you found that these architectural decisions have made maintenance a lot easier?
Mm-hmm. So every idea makes sense up to some degree. Dotty has a very functional API. It doesn't have global mutable state. One of the motivating examples for the implicit functions is the fact that, well, we pass context all over the place in Dotty. More than 2,000 lines mention just implicit context in Dotty. This context is global mutable states. It corresponds to global mutable state in Scala C. This. Scala C is one big cake where everything is this. So it's very nice to reason inside this API. It's very nice to work with it. But then you want the compiler to be fast. When you go low level, sometimes, well, in order to be fast, you need to do dirty things. You need to have caches. Making a good functional cache is tricky to say the least. Making mutable cache, which looks like a functional cache, is slightly easier and most commonly faster. So Dotty looks like a functional thing. But as I think Scala is, it's both functional as object-oriented. You can take this strong part when you have an obvious strong part. If you're going to do low-level things, mutation is the right thing to do. Thanks for the question. Okay, thank you, everybody. I was glad seeing you here.